I am Sri Jyoti. Welcome to my channel. Today's video is of conic sections part 5. So make sure that you have watched part 3 and part 4. Today we are going to study hyperbola. See, hyperbola is similar to ellipse. We learned that ellipse is the set of all points in the plane, the sum of whose distances from the two fixed points is a constant. But here the hyperbola is the set of all points in a plane and the difference of whose distances from the two fixed points is a constant. Okay, here difference in ellipse it is sum. So here see it is the hyperbola. Here these are the foci. Okay, these are the foci F1, F2. Okay, see here these are two fixed points F1, fixed points F1 and F2. Okay, see here let us take any 2 points here P1, P2. Okay, another point let us take from here P3. Okay, the definition says the hyperbola is the set of all points in the plane, the difference of whose distances from the two fixed points is a constant. That is, see here F1, P1, okay, and okay, P1, first we will consider the point P1, okay, so P1, F1 and P1, F2, okay, see, so it is the long length means P1, F2, right, so P1, F2 minus P1, F1, that should be is equal to, here let us consider next P2, F1, okay, here P2, F2, so P2, F2 is larger, okay, so P2, F2 minus P2, F1, okay, that is, okay, next let us consider P3, the point P3, F2, okay, and P3, F1. So here P3, F1 is larger, right? So P3, F1 minus P3, F2. Okay, it is the definition of hyperbola. That is, it is the set of all points the difference of whose distances from the two fixed points is a constant. Okay, fixed from distances are same, difference of whose distances are same. Okay, see here P1 F2 minus P1 F1, okay, that is equal to P2 F2 minus P2 F1, okay, that is difference of whose distances from two fixed points is a constant. Okay, so here next P3 F1 minus P3 F2. All these, if we take many, we can take many points, okay, on the hyperbola. Okay, so all the points, so see here it will be satisfying all the points on the hyperbola. Okay, so it is the definition. Now here let us take this point is A0. Okay, that means this distance be A. And let this distance be C, then this point is C0. Okay, so here what about this one? This should be same, right? So here it is the point minus A0, right? So since it is in minus x-axis, so this point is minus C0. Okay, and now let us write the equation of the hyperbola. So here also same as ellipse, see here the relation between ABC, that is here C square is equal to A square plus B square, okay, and let us write the equation, standard equation of the hyperbola, x square divided by A square minus y square divided by B square is equal to 1. See, it is the standard equation of the hyperbola. See, if the hyperbola along with x-axis, okay, if the hyperbola along with x-axis, the equation, standard equation of the hyperbola is x square by A square minus y square by B square is equal to 1. If the hyperbola is along with y-axis, that means, see, if the hyperbola is in this way, see what is the equation? y square by a square minus x square by b square is equal to 1. Okay, see, if the hyperbola is along with y-axis, the standard equation of the hyperbola is y square by a square minus x square by b square is equal to 1. So here also the eccentricity E is equal to same as ellipse, that is c by a, and length of the lattice rectum, lattice rectum is 2b square divided by a, that is same as ellipse. Okay, see, from the definition of from the derivation of definition, we will get the same thing, lattice rectum, length of the lattice rectum. It is the derivation same as ellipse. Okay, so here also we will get the length of the lattice rectum is 2b square by a. Now let us go through some questions of hyperbola. First question, find the coordinates of the foci and the vertices, the eccentricity and length of the lattice rectum of the hyperbola. The given hyperbola is, equation of given hyperbola is x square by 16 minus y square by 9 is equal to 1. Say, it is of the form x square by a square minus y square by b square is equal to 1. Right? So here, therefore, it is of the form this equation, standard equation. See, when we compare with the standard equation, we know that, see, this hyperbola is along with the x-axis, therefore foci and vertices are lying on the x-axis, right? So here, first of all, let us by comparing these equations, let us find a and b. So here a square is equal to 16, b square is equal to 9. That implies a is equal to 4, b is equal to 3. Okay, so let us find foci. Foci means, that is to find the foci, C0 and minus C0, therefore we have to find C. C square is equal to a square plus b square equation, that is the relationship between a, b, c. Okay, that implies C square is equal to a square plus b square is 25. So this implies C is equal to 5. Okay, therefore the foci are, coordinates of the foci are 5, 0 and minus 5, 0. Okay, since these foci are lying on the x-axis, so here y coordinate is 0. Okay, so 5, 0 and minus 5, 0. Next, vertices. Here, since the vertices are also lying on the x-axis, here first minus a0, okay, that is y coordinate is 0. So let us see, here we have a value, right? So directly we can write vertices. The coordinates of the vertices are 4, 0, minus 4, 0. Okay. Then after that, eccentricity. Eccentricity is equal to C by A. Okay. E is equal to C by A. What is C? 5. 5 divided by A, that is 4. Okay. So E is equal to 5 by 4. Eccentricity 5 by 4. And length of the lattice rectum. Length of the lattice rectum formula 2b square divided by A, that is 2 into b is, b square is 9 divided by A is 4. 2 2s are, so 9 by 2 is the length of the lattice rectum. See the next question. Same thing we have to find foci, the vertices, eccentricity, length of the lattice rectum of the hyperbola. So the equation of the given hyperbola is 9y square minus 4x square is equal to 36. So first of all, we have to make this equation in the form of this equation, right? For that, we have to divide throughout this equation by 36, right? So that we will get 1 in right side. So here let us divide this equation by 36. 9y square divided by 36 minus 4x square divided by 36 is equal to 1. Okay, that implies y square by 9 minus x square by, y square by 4, right? 9 fours are. So y square by 4 minus x square by 9 is equal to 1. See, it is the equation of the form, second equation, that is y square by a square minus x square by b square is equal to 1, right? That means here in this hyperbola, the hyperbola is along with y-axis, therefore foci and vertices are lying on the y-axis. Here x coordinate is 0. Okay, first of all let us compare this equation with the standard equation. Okay, that is, it is of the form second equation. Therefore here a square is equal to 4 and b square is equal to 9. Okay, and a is equal to 2, b is equal to 3. So first of all let us find foci. So what is the foci? Foci is, the coordinates of the foci are, here foci are lying on the y-axis, x coordinate is 0, right? Therefore 0 b value, okay, that is not b, sorry, not b, a itself, okay. So what is a? Sorry, foci means c, right? Yes. So 0 c, 0 minus c, 0 c, 0 minus c, okay, understood, right? See here only the points are lying on the y-axis. See, point is c itself, that is 0 c and 0 minus c, okay. Foci are 0 c and 0 minus c. So here 0 c, so first of all we have to find the c value, that is c square is equal to a square plus b square, that is 13, c is equal to root 13, okay. So root 13 and 0 minus root 13, okay. So foci are 0 root 13 and 0 minus root 13. So next vertices are 0 a, because vertices are also lying on the y-axis, okay, because here hyperbola along with the y-axis, okay. Therefore vertices are also lying on the y-axis. Here also x coordinate value is 0. Therefore 0 a, okay, 0 a, 0 minus a, 0 a, 0 minus a, that means 0 to 0 minus 2. Okay, so vertices are, coordinates of the vertices are 0 to 0 minus 2. Okay, next eccentricity, same formula, E is equal to C by A, that is E is equal to C is root 13 divided by A is 2. So eccentricity is nothing but 13 by 2. So next is latus rectum, same formula, that is 2b square by a, substitute a and b values, okay. Next question, find the equations of the hyperbola satisfying the given conditions, vertices plus or minus 2, 0, foci plus or minus 3, 0. So here vertices and foci are given. Vertices here y coordinate is 0, therefore foci also y coordinate is 0. Therefore this hyperbola is along with the x-axis, okay. So according to these given points we have to write the standard equation of the hyperbola. That is, standard equation of the hyperbola is x square by a square minus y square by b square is equal to 1, right. So in this case the hyperbola is along with x-axis, right. So here our standard equation of the hyperbola is x square by a square minus y square by b square is equal to 1. Okay, so here first of all let us see plus or minus 3, 0. Foci, coordinates of the foci are plus or minus 3, 0. That means C value is 3, right. So C is equal to 3 and here vertices plus or minus 2, 0. Therefore A value is 2. So here compare this equation, okay, that is vertices plus or minus 2, 0, a is equal to 2 and not b, c is equal to 3, right. So let us find b value. So if we have b value, directly we can substitute these equations in this equation to get the equation of the given hyperbola. So let us see, c square is equal to a square plus b square, that implies 9 is equal to 4 plus b square, that implies b square is equal to 9 minus 4, 5. So b is equal to root 5. Okay, now we have got b value. B is equal to root 5. Directly substitute in this equation. So x square by a square 4 minus y square by b square is b is root 5, b square is 5, that is equal to 1. So it is the required equation of the hyperbola. Next question. Find the equations of the hyperbola satisfying the given conditions. Foci is given plus or 5, plus or minus 5, 0. The transverse axis is of length 8. See, the transverse axis is the axis where the foci and vertices are lying. Okay. So here the length of the transverse axis is 8. That means here, see, from here to here, okay, vertices to vertices, that means A, 2A, right? So it is A plus A, 2A. So the length of the transverse axis is 2A, that is equal to 8. And here it is given foci are the vertices of coordinates of foci are plus or minus 5, 0. So here y coordinate, since y coordinate is 0, these foci are lying in x-axis. That means hyperbola is along with the x-axis. Therefore, the equation, standard equation of the hyperbola is x square by a square minus y square by b square is equal to 1, right? Because these foci are lying on x-axis, right? Here y coordinate is 0. Therefore, these foci are lying on x-axis. Therefore, the standard equation of the hyperbola is x square by a square minus y square by b square is equal to 1. So here, the length of the transverse axis is given. Okay, that means 2a is equal to 8. See, this axis is transverse axis and it is the conjugate axis. Okay, that is the opposite axis. So here transverse axis is nothing but it is the axis where foci and vertices are lying. Okay, so here first of all, foci, that means C is foci is plus or minus 5, 0. That means C is equal to 5. Okay, C value is 5 and 2a is equal to 8. That implies a is equal to 4. Okay, the length of the transverse axis is 2a. So 2a is equal to 8, a is equal to 4. So let us find b. We know that c square is equal to a square plus b square. A square is 16 plus b square. That implies c square is equal to 25. That is equal to a square 16 plus b square. That implies b square is equal to 25 minus 16, that is 9. So this implies b is equal to 3. Okay, so here b value is 3. Now we have a and b. Directly substitute this equation so that we will get the required equation, right? So x square divided by a square is 16 minus y square by 9 is equal to 1. So it is the required equation of the hyperbola. Next question. Find the equations of the hyperbola satisfying the given conditions. Foci is given. The conjugate axis of length 24. Conjugate axis of length is 24. Okay. So here foci is given. The foci is 0 plus or minus 13. Since x coordinate is 0, these foci are lying on y-axis. Right? So here hyperbola is along with y-axis. Therefore, C is equal to, okay, foci is 0 plus or minus 13. Therefore, C is equal to, okay, first of all, let us write the standard equation of the hyperbola. Okay, since these foci are lying on the y-axis, the standard equation of the hyperbola is this one, second one, right? Y square by a square minus x square by b square is equal to 1. Okay, and here C is equal to, foci is 0 plus or minus 13. Therefore, C is equal to 13. And conjugate axis of length is 24. That means 2b is equal to 24. Okay, so it is the conjugate axis. So, but here the conjugate axis is of x-axis, right? In x-axis. So here 2b is equal to 24. That implies b is equal to 12. Okay, conjugate length of the conjugate axis is 2b, length of transverse axis is 2a. Okay, so here we have C and B, we have to find A, right? So C square is equal to A square plus B square, that implies 169, that is C square, 13 square is equal to A square plus 144, that implies A square is equal to 169 minus 144, that implies 25, right? That is equal to 25. Therefore A is equal to 5. So directly substitute in this equation, so that we will get y square by A square, y square by 25 minus x square divided by 144 is equal to 1. So it is the required equation of the given parabola, hyperbola. See the next question. A beam is supported at its ends by supports which are 12 meters apart. Since the load is concentrated at its center, there is a deflection of 3 centimeter at the center. And deflected beam is in the shape of a parabola. Okay, how far from the center is the deflection of 1 centimeter? See here it is given that it is the beam. Okay, so beam is, see, its two ends is supported by another material of length 12 meter. Okay, so that means here its distance is 12 meter. And the deflection, that is, there is a deflection of 3 centimeter at the center. Okay, so here see, from the center this length is 3 centimeter. Okay, and it is in the shape of a parabola. How far from the center is the deflection of 1 centimeter? See, this deflection is 3 centimeter. So here we have to find the distance from center to, okay, so from center to when the deflection is 1 centimeter. Okay, suppose the deflection is 1 centimeter is here. Okay, then we have to find this length. Okay, this length we have to find. So here it is total 3 centimeter, right? So if it is 1 centimeter, then remaining it is 2 centimeter. Okay, okay, here it is total 12 meter. Okay, it is the point, it is the total distance is 12 meter. Therefore, from center to this distance is 6 meter, right? So it is 6 meter. So this point is nothing but this distance, x coordinate is 6, isn't it? X coordinate is 6 because from center to here the distance is 6, and here y coordinate is nothing but 3 centimeter. This distance is 3 centimeter. Therefore, it is 3 centimeter. So here our x coordinate is in meter. So we should write the y coordinate in meter. Okay. So here 3 centimeter means 3 by 100 meter. Okay. Therefore, we have a point on parabola. Okay, on the parabola, that is, see this point. It is the point 6 3 by 100. Okay. Since this point is on the parabola, this point should be satisfied equation of the parabola. See, what is the equation of the parabola? See, this parabola upwards, right? This parabola is upwards. So here the equation of the parabola is x square is equal to 4ay, right? Because this parabola is along with the positive x-axis, positive y-axis, right? Therefore, the equation of the parabola is x square is equal to 4ay. Okay, since it is a point on the parabola, this point should be satisfied in this equation, right? So here let us substitute this point, that is 6 square 36, okay, is equal to 4 into a into y. Y is nothing but 3 by 100. Okay, that implies, let us find 4 ones are 4 nines are, okay, take 900, that is, okay, 3 ones are 3 threes are, okay, therefore 300, right? So A is equal to 300 meter, because this measurement in meter, okay, we converted this centimeter to meter, right? So here this measurement is in meter, therefore we have got A is equal to 300 meter. That means the focus point is length is 300 meter. Okay. So here we have got A is equal to 300 meter. We have to find this length, right? This length we have to find. See, that is the question. How far from the center is the deflection of 1 centimeter? So if it is 1 centimeter, so what is the distance from the center? Okay. So here we have to find, see, what is this point? This, it is x. Okay, let it be x. Okay, x, and this length is nothing but 2. Right? That is 2 by 100. Okay, 2 by 100. Because it is centimeter. Understood, right? Because it is 2 centimeter. Okay, that is y coordinate is 2 centimeter. And let it be x. This one we have to find. Okay, we don't know what is the distance here, distance of this one. So here it is x. Sorry, it is 2 centimeter. So let it be take x. Okay, so x 2 by 100. So this point is x 2 by 100. Okay, so here, since it is a point on the parabola, okay, so this point is also lying in parabola. Therefore, this point is should be satisfied in this equation. So here we can write x square is equal to, okay, x square is equal to 4 into 300. Okay, a value is 300 into y. Y is nothing but 2 by 100. Okay, so here is cancelled. Then this implies x square is equal to 4 into 3, 12, 12 into 2, 24. Okay, that implies x is equal to root of 24. That is here we can write root 24 as 4 into 6. Root 4 into 6, that is root 4 is 2. So 2 root 6. 2 root 6 meter, because our measurement in meter. Therefore, x is equal to 2 root 6 meter. So here the distance from the origin, okay, distance from the center to the deflection of 1 centimeter is 2 root 6 meter. Okay.